Let's take a look at this review problem. F of x equals 2x cubed plus 7x squared plus 10x minus 7. We need to factor this cubic equation. This is a cubic equation with integer coefficients, and so the standard technique is to start by using the rational root test. So possible rational roots. Things that go into the constant term would be the possible numerators, so plus or minus 1, plus or minus 7. And things that go into the leading coefficient are the possible denominators, plus or minus 1 or plus or minus 2. So this gives us 8 candidates to test, plus or minus 1, plus or minus 7, plus or minus 1/2, and plus or minus 7/2. So 8 possible rational roots. Obviously, not all 8 are going to work. This is a cubic polynomial, so this only has 3 roots. Furthermore, there's no promise that any of them will work. So let's start to do this. Back in the old days, the only way to figure out which one of these would work is to just start testing and see what happens. These days, it can be the process can be sped up a little bit by using technology. So on screen here is the graph of this polynomial, 2x cubed plus 7x squared plus 10x minus 7. And it looks like it has one x-intercept, and it's between 0 and 1. So this makes us hopeful that perhaps positive 1/2 will be a root. So let's try out positive 1/2. So we use synthetic division, 2, 7, 10, negative 7. So bring the 2 down. 2 times 1/2 is 1. 7 plus 1 is 8. 8 times 1/2 is 4. 10 plus 4 is 14. 14 times 1/2 is 7. 7 minus 7 gives us a remainder of 0, and therefore it factors. So it factors. So 1/2 is a root. And furthermore, this gives us a partial factorization, x minus 1/2, and then 2x squared plus 8x plus 14. 14 is the constant term, 8 is the linear term, 2 is the quadratic term. All right, we can do a little bit better than this because I can pull a 2 out. 2 times x minus 1/2, then x squared plus 4x plus 7. And so I've got a linear and now a quadratic. Now to factor the quadratic, I can use any technique at my disposal. In this case, I have to use the quadratic formula to find the roots of this quadratic. So if I were to use the quadratic formula, so I'm going to do the side work over here in pink, x is equal to negative 4 plus or minus square root of b squared 16 minus 4ac 28 all over 2. So this works out to be negative 4 plus or minus square root of negative 12 is 2i square root of 3 over 2, or negative 2 plus or minus I square root of 3. And so there are my 2 complex roots. So if I factor this over the real numbers, that is the factorization. And my 3 roots are going to be positive 1/2 and negative 2 plus or minus I square root of 3. And so this cubic equation has these 3 roots. One of it's real, corresponding to the one x-intercept that we saw in the graph, and 2 are complex.